I am physics drama.
My physics finals is on the week of the senior finals. So, and my AP test is on the same day as my physics final. So from 8 to 12, I have 8 to 11.
First hour had no questions, second hour had one question, so I totally get it. Huh?
What was second hour question?
I'm not telling. I don't remember. Did you have 45? I don't know, I can't remember.
Okay.
43 and 47. You had 3 days.
I did 8.1 last night.
It was 53. When we did it, it didn't seem that tough. Nothing?
I'm just doing this magical thing called I need to get caught up on math work, so I did 8.1 last night.
I've heard of it, I've never had it.
So at least I'm doing it now, right?
Yep.
There's that.
Okay, then let's get rolling.
Oh no, my nail. My poor child. Darn the evil zipper. I have an interview next year. I have an interview next period. Not next one. I have an interview for my robotics. Because they canceled it Friday. Or Thursday. And it was horrible that they canceled it. Because right before I was supposed to do it, I may or may not have just had many anxiety attacks. Which ended with me crying in front of 2 people. And I have a reputation. I don't cry. I ruined my reputation for that.
Yes, this is 8.
So yeah, it was horrible.
We only have to do it and then you test and then a group of 8.
Wow.
And then I was told that
Must
we
not get out much. Just asked if I was a sub.
Didn't he come in here the other day though?
Exactly.
Who?
Then he and I realized it was an honors class, and he said, oh, I must be in the wrong class.
That's sad.
Clearly don't get out much stuff. Well, what'd you get? 20. Yeah, the unit squared will,
I'm just not paying
when it pops up, go for it, but for now, don't worry about it. How, why, who, where? 1/2 base times height, sounds good.
Really?
Okay,
I missed a lot.
question number 2.
So we're gonna have to, do that.
Find the area. Oh, it's very quiet. Why is it so quiet?
Good question.
Last one was easy, isn't this one the same?
No.
Oh, that's why you did the thingy.
So,
Oh, I remember this.
so once upon a time in geometry, you guys found all kinds of different ways to do this. I am lazy. So I would much rather have a formula. So how about this?
Thank God.
Area.
I
In
never
this
thought
case,
I'd...
A is standing for area, please. Area is equal to 1/2 AB sine C. Yes, it is. They don't trust you.
Wait, can you bring that?
What do we need to be given for this to work, for this to be useful?
A, B, and C.
SAS
Yeah.
or SSA?
SAS.
Why SAS? How can you tell?
English beam.
The letters
All different.
are all different. Okay. AB sine of C. Could it be BC sine of A? Could it be 1/2 AC sine of B? Absolutely. So, what do we get? 8 times 5. times the sine of 71 degrees. I would guess it'd be somewhere in the 15 to 18 range. 18.9. So the area of the triangle is 18.9. Questions there? Okay. We're good?
Oh, this pen. This pen.
You like this one? Why not?
So therefore we have to find the angle.
We need an angle. So we have two options. We have three options. Option number one is we can find one of the angles by using
The law of cosines.
the law of cosines and then use the formula to get our answer. Okay? So that's option one.
Or we could be lazy.
Okay? Option number two
Oh god.
is we can use something like this.
What even is that?
What?
Hard pass.
You don't want to do that?
That's like huge, man.
That's what she said.
27
Hi.
steps to find the area of one little stinking triangle. So that's option two.
Let's do option number 0.
Option three. Please, there's just too much yapping. Option number three says that there was some guy once upon a time whose name was Heron. And guess what he came up with? Formula. And the name of his formula is? Whoa, you guys are good. And Heron's formula says that the area of a triangle is equal to the square root of S times S minus A times S minus B times S minus C. Which begs one question.
What is S?
What is S?
The side.
S is called
Oh.
semi-permeable.
Semi.
Semi-perimeter. S is the semi-perimeter. If you had to take a wild guess, what would you say that semi-perimeter means?
Like half of the perimeter.
Half of the perimeter. What's a semicircle? So therefore, a semi-perimeter is half the perimeter. In this case, what is S?
12.
Wait,
S is 12.
16.
So Heron's formula says that the area of this triangle is equal to the square root of 12 times
12.
Minus 5.
12 minus 5 times
12 minus 8.
12 minus 8 times
12 minus 11.
12 minus 11. Feel free at this point to plug that whole thing into your calculator, unless you want to simplify it first, and simplifying it first is fine here. If we simplified it first, we would get 12 times 7 times 4 times 1. 84 times 4 is 336, so the square root of 336 is what, about
18.3.
18.3.
I charged my calculator last night.
Questions there? We have now completed 8.3. Remember how yesterday I was saying that we could get caught up today? This is why. Because 8.3 is simply a couple of formulas. That's really about it. So, we're going to use this day to get caught up.
Made in the Philippines.
Questions
I
on
know something else that was made
8.3,
in
questions
the
on the
Philippines.
area of a triangle.
My best friend.
We dealt with 3 triangles, found
Lucky.
the area of all of
But I
them.
just said,
Life
I
is
know.
good.
I said this was made in the Philippines. I know something
Questions?
else that was made in the Philippines.
There must be questions, because there are a lot of people talking. None? Oh, okay. You're just messing with me. I understand. So, we're going to eliminate areas of triangles, and we're going to get into section 4. Ready for section 4?
Are we?
I don't know. Section 4 will start today and will finish tomorrow.
Oh.
Will?
I don't know.
Supposed to. After today, we'll be caught up.
Oh, this is 8.4A.
That
So our
is.
test is Monday, right?
I don't know, I haven't looked.
That comforts me. I don't know whether or not I meant that.
We're going to talk about vectors.
That's a
No.
non.
Test is Tuesday. Oh, no, test is Monday. Group test Tuesday.
Oh,
Welcome back
yikes.
to group test. God, I always pick the groups. I can't let you guys pick the groups.
Ooh.
Wow.
People together, and then you put a lot of people with the same intelligence together. That doesn't work.
Doesn't it?
Everyone who is with her as a partner remembers.
That doesn't work? Wow, last I checked on every group test, everybody's average went up. And then your average must have been 100. I can't believe people are complaining about tests that people have done very well on and bumped averages up. It's strange to me. I don't understand it. We can have 2 options on this. Option number 1 is I can pick the groups and keep the scoring rules the same. Option number 2 is you can pick the groups and I can change the scoring rules to make it like a regular test. Keep it the same? Okay. I think that's probably a good idea.
Oh.
That's a line.
For the last couple of years, what have you called that?
Line.
You've called that array.
I feel you. I feel you.
It's deflating my life.
It's not a line. It can't be a line. Could have been array. But
I
now
found
we're
something my
going to call it a
screwdriver
vector.
works on.
What is a vector? A vector is not a line. A vector is not an array. A vector is.
Why?
Okay, why don't you guys let me run with this for a couple minutes, okay? Thank you. A vector is not a line. A vector is not an array. A vector
I'm kinda
is
scared to take
a
this out.
segment with direction. That's how we will treat it for the time being. Eventually, vectors will be things like forces, stuff like that.
Physics.
But for right now,
Sophia starts crying.
we're simply going to call it a segment with direction. In that case, this has a starting point.
Battery.
Where?
I don't know why seeing the battery surprised me.
If it has a starting point, does this have an ending point?
No.
What did I just call it?
Segment.
A segment with direction. Does a segment have an ending point? Yes, this has an ending point. Where's the ending point? The end of the arrow. It's the ending point. Okay? He always wants me to wait. Starts at the beginning, it ends at the end. A segment, or
This really?
a vector has 2, well, we can write a segment in 2 different ways. One of the ways that we can write it is with its
Starting point?
One of the ways that we can write it is dealing with its length. Does a vector have length? Or does it have infinite length?
It
It has a length because it's a segment. Okay, so it does have a length. Right? We will look to find that length quite often. Another name for the length of a vector is magnitude. So the length of a vector is also known as the magnitude of a vector. So let's start with a vector that starts at the point -2, 3 and ends at the point 3, -4. So we are looking to find the magnitude of vector AB. Let's take a look at that for a second. So -2 and 3 would be about there. 3 and -4 would be around in there. Does that look right?
No.
Why not? It doesn't have direction. Where should the arrow be? The bottom. Because this is point B. This is point A. This tells us that the vector starts at A and goes to B, so this is our vector AB. Can we find the magnitude of that vector? How? Distance formula, aka Pythagorean theorem. In order to use the Pythagorean theorem, we would need a triangle. Could we draw a triangle here?
Yeah.
How?
Draw it.
Yeah, I'd probably go down. I'm used to that. Do something like that? Okay. That's a right angle, right? Which means that once that's a right angle, we can now use the Pythagorean theorem. So, continue. 7. 5. So 7, 5. So 7 squared
Plus 5 squared.
plus 5 squared, and then what do we do with that? Take the square root. Which gives us,
Square root. Did I add that?
74.
Square root if I didn't add that right.
so the magnitude, which you will see written like an absolute value sign quite a bit, in this case is the square root of 74. Square the change in x, square the change in y, add them together, take the square root. Pythagorean theorem, distance formula, it's all the same thing. Questions there? So a vector has, I said, two components. It has the magnitude, but it also has direction. It's one of the things that we've talked about. Because it has the arrow, it has a certain direction that it goes, and we at times will have to measure the direction. How do we measure direction? A great question. How do we measure direction? Do we say, like in this case, it goes down and right? Is that a good measurement of direction?
Good start.
Absolutely not. Because how would that vector, if I said down and to the right, couldn't that be the same thing?
Yeah.
Are they the same vector? No. Vectors must have,
Specified direction.
let's try that again. Equivalent vectors, vectors that are the same, must have the same magnitude and the same direction. But that being said, if they have the same magnitude and the same direction, the location can be wherever we want. So in other words, we have this vector right here. Well, if we put that same vector down here, is it the same vector?
Yes.
It absolutely is. What about if we put it up there? Yes, as long as it has the same magnitude and direction. Yeah. So would the pink vector be the same as the black vector?
No.
No, because they have different
Direct.
directions. It looks like the magnitude's pretty similar. I don't know for sure, but it looks like they're pretty similar. But they do have different directions, so they would not be the same vector. Okay? So, how do we measure some of that stuff? Question. So, another way that we can talk about vectors is by using their components. Here's what I mean by that. Okay. We are going to talk about a vector, and a lot of the vectors that we talk about are going to be called vector U. We use x as variables a lot of times and stuff like that. With vectors and with angles, we call it theta. With vectors, we tend to call them U. We might call them V if we have a second vector or something like that. So, vector U, I think that's the one I wanted, 4-7. Yep. You may notice the, I don't know, bracketing or whatever around them. And you'll notice that it's not a parentheses, it's not an absolute value, it's not a standard bracket. It's almost like a greater than and a less than sign or something like that. Okay. That's something else that you're going to see in vectors. When it's written like that, that is called component form. But that's called component form. Component form basically says that it's going to move, in this case, 4 units in the x direction and 7 units in the y direction.
Does it matter up or down, up, down?
Well,
Is that what
x direction and y direction. So if we're going 4 units in the x direction, we're going 4 units right and 7 units in the y direction up. So would this be a reasonable drawing of vector u in this case?
Sure.
I mean, I don't know if it's exactly to scale, but that would be in the ballpark. Fair?
Yeah.
So we want to find 2 things. We want to find the magnitude and the direction. So, find the magnitude. Go. Is the magnitude of that vector 65?
No.
It's the square root of 65, so that is fair. Good. You'll notice that I wrote the u inside like an absolute value sign. What does that mean? That means magnitude. You may come across something. In fact, for me, every book I've ever used until this one has said this. It has done magnitude as kind of like a double absolute value sign. Our book does it as a single one, so I won't do that, but just so that you know, if you ever see the double absolute value there, that basically means the magnitude of a vector. Okay, now we got to find direction. How do we measure direction? We just said it can't be down and to the right. That's not, or in this case, up and to the right. How can we measure direction more specifically? Angles. Oh, wait. We're doing trig, right? Triangle. Ah, I got you. So let's do this and this, and then let's find that angle theta right there. It's trig, right? We're in the trig time. Let's do it. So, talk to me. 4 across the bottom. 7 on the right. That's actually all I care about for right now to get the angle, because what am I going to do?
Sine, cosine, tangent.
Which in this case will be tangent of. Tangent of
Theta.
theta equals 7 over 4. What now? Throw it on your calculator. Right? We're trying to find the angle, so you'd better hit the second function button. Second tan, 7 over 4. Theta is
60.2 degrees.
60.3 degrees.
Yes.
What is the magnitude of the vector? Square root of 65, what is the direction of the vector?
60.3.
60.3 degrees, you got it. There are two different ways that we can talk about a vector. We can talk about it in component form, which would be x and y. How far do we go to the right? How far do we go up? Or we can talk about it with magnitude and direction. So in other words, to get from here to the circle K, instead of going 4 blocks this way and 7 blocks this way, let's just walk right through everybody's yards and go the square root of 65 blocks at an angle of 60.3 degrees. Which way's quicker? As long as there are no fences or dogs, right? Why would your neighbors what? As long as your neighbors are okay with it. Yep. Yep. Questions there? We okay? Let's do another question like this.
So that's our direction, 60.
Let's say that u in component form is -6, 3. And I would like us to find the magnitude and the direction. Go! Most people will get about 2/3 to 3/4 of this right, and won't get the very last thing. Everybody's here, right?
Yeah, totally.
Okay, did you get, do we have the magnitude? Yes. The magnitude of u is?
3
I am not a big fan of the square root of 45.
root.
I'm a big fan of 3 root 5. So we will obviously need to simplify these, so make sure you are doing that. Okay, now what about the direction?
26.6, negative 1. Shouldn't it be negative because the quadrant?
You can have
Tell me what to write. Tell me what to do. Tangent of theta
Equals
3 over 6.
Yes.
Negative 3 over 6.
No.
3 over negative 6.
3 over 6.
Doesn't really matter, does it? And so theta is what?
Negative 26.6.
Negative 26.6 degrees. So, is it fair to say that the magnitude is 3 root 5 and the direction is negative 26.6 degrees? No? Why not? It's the same reason that we have talked about constantly for the last 2 months. Quadrant. Quadrants never go away. What quadrant should our angle be in? 2. Why?
Because tangent.
Because that's where the point is, right? Okay. I typically, unless I feel really confident, I'm going to draw it. I typically draw it. Now in this case, you did all the mechanics right. Okay? We got all the mechanics right. We're going negative 6 and up 3. Okay? So seeing that might say to you, it's in the second quadrant. If it doesn't say that to you, make it say it to you. make sure that you don't forget quadrant. Maybe that's something you write a note at the top of your tests or whatever, or your homework or whatever. You know, don't forget quadrant or whatever you need to do. But you can tell from looking at this that we are in the second quadrant. So this would be 3, this would be 6, inverse tangent of 3 over 6. Okay? And whether you do it as positive or negative, I don't really care, because what are we trying to find? The reference angle. And what is the reference angle here? 26.6 degrees. But this vector ends in the second quadrant, and so to get the correct angle, we need to subtract it from 180. So 180 minus 26.6 gives us a real theta of 153.4 degrees. Is it fair now to say that the magnitude of the vector is 3 root 5 and the direction is 153.4 degrees? That is fair. Don't forget quadrants. Don't forget quadrants. Okay? Questions there? Because we want this to get to the second quadrant. So this is that 26.6 degrees. But we want to find the angle that it makes, so basically we want to find that angle. And so to get there, we'll do the 180 degrees from there minus the 26.6. Does that make any sense? And that'll get us this angle around there. Okay? Any other questions on this? You weren't pointing like a question, you were just pointing at something. Just wanted to make sure I wasn't ignoring you, that's all. Okay. Let's see what's next. So, let's say that we have two vectors. Two vectors. We have vector u, which is 5 and negative 2. In what form? What form is this in? Component form. And then we also have vector v, which has components of negative 2 and 6. And one of the things that they are going to ask us to do here is they're going to ask us to add vectors together. Now, can we do that? Remember what I said vectors are eventually going to turn into. It's going to be like force. Okay, so you're going to have one vector that's a force of this, and another vector that has a force of this. So where we're really eventually going with this is we're really kind of getting into physics.
Lovely.
Okay, so you have one force pushing from this angle, and you have another force pushing this angle.